Hey guys, Mr. Barnes here again, bringing you another math video. This one, another trig proof video. So, I've been doing in my class recently some trigonometric proofs, which I should have had done long ago, but we had delayed because of the snow days. So, the first thing I always tell my students to check for is expanding or FOIL. The other thing I get them to check for is factoring. So if you have factoring in your proof, there's a good chance that you need to do it. So if you look at this guy, you can kind of see that, there's a few things we can do with this side, and there's a couple of things we can do with this side. But if you look here, we have a cosecant x and a cosecant x, and I always tell my students it's easier to bring things together than it is to break it apart. So this has a minus sign. It's easier to combine those than it is to try and break this apart, because when we break this apart, we're guessing at what it should look like, whereas it's a little more intuitive if we have to bring something together, via a common denominator. So we're going to start with the left-hand side, and what I'm going to do is I'm going to factor a cos x out of this guy. So if I take a cos x out, I'm left with 1 minus sine squared x. So that sine squared x, that's a derivative. I shouldn't say that word. That's a different form of the Pythagorean identity. So that's actually cos squared x is equal to 1 minus sine squared x. So you see sine squared, you think Pythagorean identity. So you shove this guy in right there, so it becomes cosecant x times cos squared x, and that's equal to the right-hand side. And we are done our proof. So simple as that, guys. Like when you see factoring, try and factor out something. Also important to remember, I took a cosecant out. Make sure you leave that 1 there. You should always just do a mental check. If I multiplied this back in, would I get the same thing as I had up here? So you would, so we did it right. Alright, let's try one more. So, I've got another situation where factoring is best. So you can see not much I can do over here. I mean, I could, write this as sine over cos and then probably find a common denominator. But you can see immediately here, I can take out a secant x. So if I take out a secant x, it might be worth doing. Another thing I could think about is the fact that this secant times cos is also 1. So there's a lot we can do over here, including factoring out a secant. Although I don't know if that's the best one with it, the best route to take with this one. So I could, but I also have to recognize that secant times cos, those are reciprocals. So that's 1. So I'm actually not going to take out a common factor here. I'm just going to actually change this to 1, and then I'm going to change my secant to 1 over cos x here times sine x. So sometimes, guys, you get this in a proof, you say, oh man, that's definitely factoring, but then you look at it and examine it a little bit more. It's not actually it. So that's why I think it's important to recognize that secant x times cos x is 1. So that's 1 secant times sine, or cosecant times sine, and cotangent times tangent also equal to 1. So this becomes sine x over cos x, and then we actually get our proof just like that, which is the right hand side. So sometimes, guys, you have factoring and it might not be the best route to take. We could have tried it and it mightn't have worked. We left with cos plus sine inside, so that really doesn't leave as much to go. So always, check other options as well. Don't just think about it. But I think factoring is one of the primary techniques that you want to think about. Alright, guys. Hope this video helps you in your quest to figure out this mutant topic. Thanks for watching, and I'll see you guys in class.